So now that we have finally produced our mobile application, is it ready to be released? Not just yet. We finished creating it, but how do we know that it's actually going to behave the way we want it to? Are we absolutely certain about what we have created? How can we find out if there are any problems? Well, that's why phase 4 of the software development lifecycle is testing. This is exactly what we are going to evaluate. So what we take from the SDLC in step 4 is the product, what was created in step 3, the actual application, everything as it should exist when it's released to the public. We're not doing that just yet. We have a few tests we need to run. Now, in the world of testing, there are many different tests that exist. We're going to focus on these 3, the usability test, functional testing, and security testing, with a bit more focus on the security side. With usability testing, what we are evaluating is, does the application provide a good user experience? Remember when we discussed bridging that gap during phase 2 between the developers and the users so that it could be relied upon, look good, and everything works together as intended to provide a great user experience? Well, that's what we're evaluating here. These are just some sample questions to ask and have evaluated during the test. For example, is there a back button? Well, one is provided for Android applications, either by the device or by the operating system. You don't really need to worry about that. But what about iOS devices, iPhones, iPads? There's no back button provided. You must have that within your application. If you forgot it, if it wasn't included, if there's no way for a user to go back when they need to, that's a very bad experience. That's going to fail the test. You should also keep in mind how your application is going to behave when it receives a phone call. Not your application, the device that the application is running on. We are, after all, creating applications to run on phones. We can't replace the ability to take a phone call. No, we need to allow them to happen. Take, for example, a game. If you're playing a game and you receive a phone call, after you finish the phone call, you go back to your game. What happened? Did the game detect that there was a phone call and it paused so that way after you finished the phone call you could resume the game where you were? Or did it continue to run in the background on the phone while you were taking the call? If that happened, after you hang up and you return to your game, you may find that you've lost your progress and have to start over. That would be a bad user experience. So these are just some of the things to evaluate when you are deciding if the application that has been created is indeed providing a good experience to your users or not. Moving on to functional testing. This is where we test if the application is actually behaving in the manner that we expected it to behave. This has some crossover with the usability testing, because if it doesn't behave as we expect it to, that's a bad user experience. But it also has some crossover into the security realm. For example, the data input. What happens if it's not what we expect? Does the application crash? Am I potentially receiving a SQL injection attack? How do I handle that? Are the text fields going to allow the same amount of data that the database can store? If not, best case scenario is that someone's name is cut off because it's longer than the text box or the database would allow. Worst case scenario is that I am somehow able to create a buffer overflow on your server through that exploit. And now you have a very serious security situation on your hands. So let's explore more of the security side of testing. We're going to focus on 3 kinds of tests: static analysis, dynamic analysis, and we're going to discuss a bit about penetration testing. Let's focus on static analysis first. This is a security-themed review of your source code. Think of how a debugger goes through your code to find any problems with the code that would prevent it from executing. Most static analysis is handled by automated programs, except they're not designed to look for problems with your code. They're designed to look for potential security problems that might exist with your code. Here's a good example of it. This block of code actually comes from a version of the OpenSSL application that was vulnerable to the Heartbleed bug. In fact, the arrow that you see is pointing to the very line of code that was not programmed correctly, which created that security vulnerability. Now, this was missed. So don't think that static analysis will catch everything. But this is an example of just how meticulous static analysis can be and how valuable it can be in finding these problems so they can be fixed. Now, while static analysis is a review of the code itself, dynamic analysis is the testing of the code while it is running. So we're actually executing our application and testing it that way. We're putting it through a battery of tests. Some examples of what that testing might be would be feeding it bad information, out-of-band data, invalid input. Basically, through a process called fuzzing, what happens if we throw all of this data at it and it crashes? First, does it crash? And if it does, what kind of an error does it give you? What if that error exposes some of the program code? That's a vulnerability. The more I understand the code, the more I can understand how to break into your application and your service and the servers supporting it on the back end. Penetration testing, this isn't automated. This is something done by skilled professionals. In fact, penetration testing is done by something called hackers. Specifically, people who usually carry a certified ethical hacker certification. But these are security professionals who have such experience and knowledge about information security that they come at your request to perform testing against your service and your application to see what security holes may exist. Now, these tests are usually conducted in one of two forms. There is a white box test and a black box test. A white box test is where you bring in someone to do a penetration test and you give them information to help them with their test. This is good in that it helps them to find more detailed evaluations. They can dig deeper into systems that they may not have known were there and try things that they may not have tried before because they have the information that you gave them. So white box testing can be very detailed and very in-depth, but it's not very close to real life. The point of a penetration test is to evaluate your vulnerability to a malicious attacker. So why would you ever give information to help your attacker? That's where black box testing comes in. Unlike white box testing, you are bringing someone in to hack into, to try to break into your application or service, but you aren't giving them any information to help them with that task. They must find it all on their own and do what they can with it to see how far they can get. Now, regardless of the test that's performed, all of the results are evaluated, put into a report, and given back to you so that you can begin to evaluate how to make these repairs to your application or service. However, it's important to understand who it is that you are hiring to do these tests. That's where the type of hackers come into play. They usually exist in three different forms, and these are terms that are created by the community of security professionals. Hackers wear hats. White hat, black hat, gray hat. What do these mean? White hat hackers. These are your certified ethical hackers. Think of the difference between a locksmith and a burglar. They both possess the same set of skills, how to open a locked door. However, a white hat hacker, like a locksmith, would only do that at your request for your benefit after getting the necessary verification that you are indeed who you say you are and that you are indeed properly approving them to perform this action. Burglars, on the other hand, these are black hats. They possess the skill to open locked doors, but they're going to do it when you aren't around. They're going to do it without your permission. They're going to do it for personal gain. They're going to break into your house not for you, to help you, because you forgot your keys. They're going to do it because they want to get in there. They want to find jewelry, art, money, anything that's valuable for them to take for their own benefit. And in the world of information security, that is your customer data. Gray hats, these are people who tend to do a little bit of each. This could be someone who could be a white hat during the day, but at night as a hobby goes and engages in black hat activities. Who should you hire? It should be pretty clear. You only hire a white hat. Someone with a reputation that can be trusted, working with a company with a reputation that can be trusted. Hire a white hat to test your applications, your services, and your systems. If you do not, it's only going to be a matter of time before a black hat manages to break in and steal your data.